Hello and welcome. Today, we're going to pull back the curtain on one of the most powerful forces shaping our world, the algorithm. And we're not just going to talk about it. Oh no. We are going to build one together, right here, from scratch. So let's just jump right in with a question. What on earth could a simple recipe for a cake possibly have in common with the most complicated app on your phone? I know it sounds like a trick question, but the answer is actually really simple, and it's the key to, well, everything we're about to cover. All right, here's our game plan. We'll start with the basic idea of what an algorithm even is. Then, we're going to build one together using three fundamental rules: order, choice, and looping. And to wrap things up, we'll have a quick challenge for you and then look at the bigger picture. Ready?
Okay, let's dive right in. First things first, what is an algorithm really?
It's really just a fancy word for a set of instructions. A recipe is totally an algorithm for making a cake. Your morning routine? Yep, that's an algorithm for getting ready for the day. At its heart, it's just a step-by-step process that solves a problem and gives you the right result every single time. Now, to really get this, let's build an algorithm together. So what's our goal? We're going to create a little program that can translate any word into Pig Latin. And this is going to help us understand our very first and maybe most important building block. Let's try it with the word pig. Okay, following these steps, we take pig, add a hyphen, so we have pig dash. Then we add the first letter, P, so we get pig dash, P. Now we add A, which gives us pigpay. And finally, we remove that first letter, and boom, we get igpay. It actually works. Simple enough, right? But here's the million-dollar question. Does the order of those steps really matter? I mean, what happens if we just, shuffle them around a bit? Well, let's find out. What if we take step 4, remove first letter, and we move it all the way to the beginning? Our word pig immediately becomes just ig. Then if we follow the rest of the steps, we end up with ig-a, pay, which is definitely not Pig Latin. It's just gibberish. And that right there, that's a perfect illustration of our first building block, sequencing. The specific order of the steps is absolutely critical. It's kind of like how you can't frost a cake before you bake it. Get the sequence wrong, and the whole process just completely falls apart. Okay, so we've got our first building block down, sequencing. Order matters. Got it. But our algorithm isn't quite perfect yet. It works great for a word like pig, but what happens when we throw it a curveball, like a word that starts with a vowel? So if we run the word eggs through our current set of steps, we get gegze, which is, that's not right at all. This shows us a pretty big weakness. Our algorithm isn't smart enough to handle different types of words. It needs a way to make a choice. And this brings us to our second building block, selection. Selection is what gives an algorithm a brain, basically. It lets it make decisions. It uses a condition, think of it like a true or false question, to decide which path to go down. For us, that question is simple. Does the word start with a vowel? So check out our upgraded algorithm. See that if otherwise logic we've added? That's the decision-making part. Now, if the word starts with a vowel, like eggs, it follows a totally new path and just adds yai to get eggjai. Perfect. Otherwise, for a word like pig, it just follows the original steps we already had. So cool, right? Our algorithm can now think for itself. Okay, our little translator is getting pretty smart. It can handle words that start with consonants and vowels. But what if we want to translate more than just a single word? What if we want to translate a whole sentence? Sure, we could run our algorithm on peanut, then stop and run it again on butter, then again on and you get the picture. But man, that is so slow and inefficient. We need a way to tell our program to just keep going until the job is done. And that leads us to our third and final building block, iteration. It's just a fancy word for repetition, or what programmers call a loop. And this is the key to making algorithms truly powerful and efficient, because it lets them repeat a set of steps over and over and over again. Now look at this. We've wrapped our entire decision-making process inside one simple instruction for each word in the phrase. That one line tells the computer to run our whole translation logic on every single word all by itself. With this loop, peanut butter and jelly becomes unit pay, utter bay, and yay, LEJ. Just like that, we've built a complete, powerful algorithm. Okay, so you've seen the three building blocks in action. We've got sequencing, selection, and iteration. Now let's see if you can spot them out in the wild. So let's meet Saria.
She's writing a big research paper, and she's built this handy little tool that creates a perfectly formatted citation for a book. And it works great, for one book at a time.
Here's her basic algorithm. You can see it's just a simple step-by-step sequence of commands to get the citation formatted just right. But now, she's got a whole stack of books, and she wants to generate citations for all of them at once.
So here's the question for you. Which of our 3 building blocks does Soraya need to add to her algorithm so it works on her whole list of books? Is it A, selection, B, iteration, or C, sequencing? Go on, take a second to think about it.
And the answer is B, iteration. That's right. To solve her problem, Soraya needs to repeat that citation process for every single book on her list. And repeating something over and over, that's exactly what a loop or iteration is for.
All right, let's wrap this all up by taking a step back for a second. We've been having fun with Pig Latin and book citations, but what we've really been doing is learning the fundamental language of how computers think.
These 3 super simple ideas, sequencing, selection, and iteration, are pretty much the Legos for almost every piece of software you have ever used. From sorting your music playlist to a streaming service recommending a movie, all the way to the most complex scientific modeling. It all just comes down to combining these 3 simple structures in really clever ways.
So, I'll leave you with a final thought to chew on. Now that you know the basic ingredients, how many invisible algorithms can you spot running in the background of your own life? I bet the answer will surprise you. Thanks for joining me.